don't take any of anything I say here as gospel, because I'm just working this out as I go along. So what I'm trying to do is work out the stability calculations for this pressure hull design. So first thing I've done is I've worked out the total mass, more or less, and it's a bit of a guess because obviously I don't know what's in where, what's going to be in the boat, all the components and whatnot. But what I've done, if you look at the section analysis, I've just tried to make it as near as I can. So I've made here's my model of me, and that does weigh more or less my weight. I put batteries in at the bottom, and I've actually added quite a lot of lead ballast into the design to take it to the correct weight. So that gives me my my total mass, and that gives me a center of gravity or center of mass there, which is 53 millimeters down. So next thing I've done is I've done submerged stability. So what we've got here is a solid model. So I just turned it into one giant blob, made it all out of water, and these are the buoyant parts only, the bits that would be providing buoyancy. This is how I'm thinking it is. And I did you can do a properties of that, and the properties here show that it gives me a volume of 1066 kilograms. So that's how much it will need to weigh. So what I then did is I went back to this model here, and I added, where's that analysis gone? I added this as lead until the whole thing weighed about the same. So that was my idea for that. Then I moved on to stability. So surface stability. So what I did here now is again made a big solid blob of everything that will be providing buoyancy, and I literally just did a construction plane and sliced it down and down and down until this single body weighs the same as the total mass of this. So that is what it should displace. So that, I'm thinking, should give me my waterline at that position there, and then from here we get a center of buoyancy there, which is the center of mass of this piece, like that. Next thing I did, I did a tilt now on the surface, and this is a tilt at an angle of 20 degrees. So I know that my center of gravity is there, 53.439 down from the center line. This now shows me my center of buoyancy there, and so I can see my GM there, which is 225. Whether that's enough, I don't know. I mean, it looks enough, and sort of instinctively it looks right. Then what else did I do? I did one more. Oh, this is it. This is the now. Then you've the underwater state here is showing my gravity won't move. That's down there at the bottom, 53.439, and my center of buoyancy there in this upright position is 53. So that gives me a total of about 106 millimeters between G and B. Is that enough? I'm not sure. I really don't know. What I can do, if you start chopping things off, like this, for example. No, I need to do it in here. If I start removing a few things, like that. Actually, that wasn't a good example. Let's do the tower. Watch the center of gravity move down. And then I can obviously do the same with the hatch, remove that, moves down again. So becomes more stable. Whether I need to do that or not, I'm not sure. But I think that is my line at where it will float. That's the riding moment between there and there. And that is my G to B in the submerged state. Now, if there's anybody who knows more about this than me, it'd be nice to hear whether that is enough. 100 millimeters, I'm not sure.